Yeah. This is continued. Yeah. Factor theorem. Yeah. Oh, then go. All right, factor theorem. So we started getting our feet wet with this yesterday, but I didn't go into the actual theorem itself. So today we'll talk about the actual theorem and how to use it. So I'm on the little section that says factor theorem. Knowing that the remainder is 0 is very useful. When you divide a polynomial by x minus a and get a remainder of 0, then x minus a is a what? A factor. That's what it means to be a factor. So that first blank is factor. Okay. In other words, if I have this big long polynomial, I divide it by something, and the remainder is 0, that means this something is a factor. Because that's what it means to be a factor. It means no remainder. Yeah. Do y'all see the extra packet playing around? Oh, there you go. Sorry. The quotient, and the quotient is what you get when you divide, right? So whatever I get whenever I divide this, that's the quotient. And if I got a remainder of 0, that means the quotient is also a what? A factor. Then I have a little note here to factor completely divide by a factor and write it as a multiplication problem. We talked about that yesterday. We did it with 6. We said if 6 divided by 2 is 3 with no remainder, that means 2 is a factor. It also means 3 is a factor. And I could multiply the two factors together to give me what I started with, right? And I'm just going to do this on a bigger scale with polynomials is what's going to happen. Yep. I'm fixing to get extra. 3 ways to find factors of the polynomial to determine if x minus a is a factor. Tell me one way. Can I what? I think it also helps if I turn the slide out over it. Tell me one way to determine if x minus a is a factor. If you've got a polynomial, how do I know if this is a factor or not? Tell me some ways I can tell. I could divide, and what tells me? If I get what? And get a 0 remainder. What's another way I could tell if it's a factor? Factor the polynomial. Give me one more way. And this is a new way we talked about yesterday. Close. You're close. The synthetic division, or what's another way for the remainder theorem, right? If I plug in, so remember we're talking about x minus a. If you plug in a for every x and you get 0, that tells me it's a factor. So I could divide and get no remainder, or I could plug it in and get 0, and that tells me no remainder, or of course just factor like normal. Everybody okay? All right, let's talk about how we're going to use this. That little middle sentence is what we're going to use to do the rest of these, where it says two-factor completely divide by a factor and write its multiplication problem. That's what we're going to be doing. So look at number 7. I have f of x equals x to the third plus 6x squared minus x minus 30. And I'm telling you that a factor, I'm not asking you, is it a factor? I'm telling you this is a factor. So knowing that that's a factor, tell me what you know. You can divide it to find the other factor, right? So given a factor, always divide to factor fully or completely. All of these factors are going to be in this form, which is really nice because that sets me up for what kind of division? Synthetic, which is a lot easier than long division, right? Yes. So what goes on the outside? What goes inside? Keep going. And let's go through the process. Drop the first one. 1. Multiply and add. And keep going. If you don't get 0, you have done something wrong here because it told me it was a factor. That's what it means. Oh, please send 10th graders now. If you need to make up pictures and you're in 10th grade, go to the auditorium. All right, so what does this tell me? Remember how we did the 6 divided by 2 equals 3, so 2 times 3 equals 6? I'm going to set this up as a multiplication problem. What this tells me is that x plus 5 times, what is this? Uh-huh. Does everybody agree that this and this are the same thing? Same thing as that 6 divided by 2 equals 3, and I put the 2 and 3 together. I did this divided by this, and I put the answer, the quotient, and the divisor together. Is everybody okay there? All right. That's factored form, and now I could finish factoring it, right? Because y'all know how to factor quadratics, right? I hope you do anyway. Huh? It's what, say that again? It what? Well, I actually this piece will factor nicely for me without. Because remember, we're going to use quadratic formula when we solve, but here I just want you to factor right now. So what multiplies to negative 6x squared but adds to positive 1x? Y'all can do this. Backwards. Positive 3 and negative 2, and the reason is it's got to add to a positive 1, right? So unit 1 comes back. I told you it never goes away. So I've got the x plus 5 that stays, right? Remember, factoring completely means I look at all the parentheses that are there as I go down, and I keep trying to break them down if I can. So this one, x squared minus 2x plus 3x minus 6. Go ahead and slash it. Finish factoring that out, and we'll come back together and see if you got the same thing I did. That's old. Not yet. We will be finding the zeros, but right now I just want you to fact. Oh, yeah, I do. I lied. Yeah, find the zeros too. Sorry. I didn't look forward on the sheet. What it made the sheet. Does everyone agree now that this is factored completely? How do you know? None of those parentheses can be broken down any further, right? So I'm good. I can't do anything else with it. So where it says factored form, there's my factored form. Yes? So f of x equals, okay? So we've been factoring, right? We've been factoring quadratics. Now we're learning how we're going to factor things that are of bigger degree than just a quadratic. Now, The second line asked me for the zeros. What in the world are we going to do to find the zeros? Equal each piece to 0. So for the zeros, what's 1? -5. And tell me what you think about the factor theorem here. So given a factor, can you find all the other factors? Given a factor, can you find all the zeros? Everybody okay? All right. Let's flip over then, because I'm leaving you 8 through 11. Down at the bottom, right after 11, remember when you plug in a 0, what should you get? In other words, -5 is a 0 here, yes? What would happen if I do f of -5? What should I get? Why? It's a factor, right? Do you see the relationship here? What I divided by, I got a remainder of 0. I got a remainder of 0 because of that remainder theorem, right? Remember that remainder theorem? If you plug it in, you should get 0. You should get your remainder. Okay, so when you plug in a 0, you should get 0 back. So that first blank is 0. Bless you. I've got some steps here for you. Because instead of factor completely given a factor, what happens if I'm asked to find all zeros given not a factor this time, but given a 0? It's the same thing, but here's the difference. So by having a 0, you actually have a factor, right? Because x minus, and I'm going to put 0, but this is not 0, the number. This is like an x-intercept 0, right? This is always a factor. So if you have a 0, you technically also have a factor. So I've got some steps there of what we're going to do, but let's flip over to number 12 and let's work through one because it's easier to see through an example, I think. So this is number 12. Yes. All right, so this time I'm starting with a 0. Okay, so I'm telling you x equals 4 is a 0. Find all the other zeros. So look at your first step over here. Divide the polynomial by x minus 0. Why am I doing that? Because one of the factors is x minus 4. Do you agree with that? What goes outside the division sign? What number? +4 or -4? I hear both. It's all right. So listen, this is where everybody gets confused. Yeah. When you're dividing, if you divide by a 0, it's the same sign. If you divide by a factor, it's the opposite sign. Okay, so I'm given a 0, so I could put just 4 outside. But it's still synthetic. This is all going to be synthetic, so it should be a lot quicker for you. All right, what goes inside the division? 1. All right, divide it out and see what happens. What should I get from my remainder as I go through this? 0. If I don't, I've done something wrong, right? Because they told me that 4 was a 0, and if I divide by that 0, I better not get a remainder because that's the definition of the 0. So Run through it quickly and see what you get, and then we'll come back together. Is what one hard? This one? No, this is just like. So make sure if it's the 0, you're dividing by the same sign. If it's the factor, it's the opposite sign. You have both, right? Because if they give you the 0, well, you know the factor is x minus that number. So
Because like if it's x equals 4, then you have to change that to x.
right. Yes, that's a 0. But if x equals 4 is a 0, that means that I actually have a factor because x minus any 0 is a factor. So if you start out with the 0, if they say x equals 4 is a 0, when you divide, you keep that sign the same, so positive 4. But if they give you a factor to start with, x minus 4, you change the sign when you divide to make it positive. Yeah. So the steps for this one are going to be exactly the same as what we did before now. Now we're right back in the exact same territory. Factor the polynomial completely. So now that you've divided, tell me what this looks like. Set it up as a multiplication problem for me. Let's see. X minus 4 times, that's right, x squared minus 4x minus 12. Where is all of this coming from? The 4 is coming here, and all of this here. Okay, it's just a multiplication problem. Now do what you do. Factor the quadratic. This whole picture thing is ridiculous. All right, when you finish factoring your quadratic completely, look up and let's see if we got the same thing. Everybody okay? Now that wasn't all I was asked to do. I was asked to find all the zeros having been given a 0. So I haven't done that yet. What are the zeros of this function? 4, -2, and positive. Again, I should get how many answers? Y. The degree is 3. That's exactly. Look at y'all. You don't know what's happening? Okay, write down and see. Um, Factor completely. Given a factor. And find all zeros. Yep, that you're exactly right. Given a 0. if I'm given a factor, I'm gonna divide by the factor. This is where I said, remember, with synthetic, this is opposite sign. Yeah, last night you should have gotten through, what, 12 or something? Oh, through 6. And we did 7, so do 8, 9, 10, and 11. 13, 14, and 15 on this. Through 15. Make sure it's done through 15. And then I got an assignment front. That'll be like your classwork part. And then I got a homework sheet for you. But you shouldn't have any problems getting through both of them. Write as a multiplication problem. And then factor completely. But if I'm finding all zeros given a 0, I'm still going to divide by a factor, but the factor this time, since I wasn't given a factor, is x minus this 0 that was given, okay? And when I do that, it's the same sign as the 0. And then I am going to repeat steps 2 through 3 above. And set equal to 0.